I, once again, have a couple of announcement type stuff I figure we'll start with earlier. By the way, for people who show up late, this kind of sucks.
No, it's good.
Well, you need some elbow room?
I do. I like to put space.
Okay. If you guys can, when you come in, kind of move more closer to the center. You can leave one spot, not three maybe, just so because people have to. I'm not going to let them sit behind the last row, so there are going to be people sitting there. So 2 things I'm curious about for announcements today. One is, are you the kind of person that enjoys having discussions, debates based on data and evidence? Like when you talk to your friends and like a social issue comes up or a political issue or environmental issue, do you get really annoyed when people are like just spouting off stuff and it like has no basis in fact?
Yes.
So there's a student organization that was started last semester and is going to be ramping up this semester. It's called the Young People Civic Association Committee. It is a group of young people who are very interested in having civil discourse with other students all around doing research on a particular topic. So a couple of students will do research every week, or every time the meeting happens, so maybe every few weeks. They'll present their data that they found on a particular issue that they're really interested in. Maybe it's funding in schools in Little Rock, unequal versus equal funding in schools in Little Rock, I don't know. Maybe it's solar energy, whether Arkansas is going to take that on. Whatever issue it is that people are interested in, they're going to spend time researching that, and then they're going to have a forum where they invite everyone to come in. They're going to present what they found, and then there'll be a discussion about that topic. The idea is to have discourse based on facts and data, and respecting each other's opinions. So if you are interested in being part of this group and maybe doing one of the presentations during the semester, let me know. There are a few students who already expressed interest in leading some of these sessions, but we would like to hear from a lot of different people. It has nothing to do with course credit, but it is people who are interested in making a difference and understanding things better and having civil discussion with people who are like-minded and different-minded. So if you're interested in that, it's YPCAC, Young People Civic Association Committee. Please send me a note. And once we have a cohort of people, then we'll set up some meeting times, and we'll get together and figure out what people want to research. All up to you. And then be participants in the ones where you don't do the research. I think it's going to be a really powerful thing we do here on campus, and started by students last fall. If you remember Kiana Momfrey, she was in our class. So she started it along with Josh. And yeah. Second thing, can you remind me who's interested in medicine as a career? Okay, a lot of people. This fall I mentioned something and I never followed through on it. I would love for people to be aware of all of the different things that you can do in medicine and helping people that is not being a doctor, as well as interested in different types of being a doctor. So I am interested in having a, I don't know, we call it colloquium, informal gathering, maybe even getting some funding for food before class on like Wednesday night or Monday night or something like that, for an hour, hour and a half before class. It'd probably have to be Wednesday, I think, because I have office hours. Well, maybe we can think about that. But I want to know if I was able to get biomedical researchers, people that work in actuarial science, people that are surgeons, people that are family practice doctors, to come here and present what they do for maybe 20 minutes a person, have 2 different groups come, so 20 minutes for one person, 20 minutes for the other person, and then like a 30, 40-minute Q&A afterwards with food. Would that be of interest to you guys?
Yes.
Raise your hands if you think you might come to that. Depends on scheduling. I had dinner last night with some researchers, some biomedical researchers at UAMS, and they said that they were really interested in having UALR students work with them as undergraduate researchers, but also as graduate students. So they want to start building a connection between our programs and their programs. So I think there's a lot of opportunities there, and I'll try to help facilitate those. So I'll try to find, I don't want to do another doodle poll. Maybe I'll go back and look at the doodle poll results to try to figure out when might be a decent time for you guys. Wednesday before class, if we did that, would anyone be able to come Wednesday before class? It's actually a decent number of hands. So tentatively, that's our plan. I probably won't start for about 2 weeks. I'll try to line someone up every week, and it'll be, actually the person I talked to last night is a basic researcher. She studies ovarian cancer by using viruses to manipulate cancer cells. And she was talking about her coming in for a while. She has a UALR technician that went to UALR that now works in her lab, a graduate student. She'd have all three of them talk. And then she would bring in an ovarian cancer survivor for the other portion of it. So I feel like that could be pretty cool. So you get to see the clinical impact of basic research. I think I mentioned I have a friend who does orthopedic trauma surgery, another one who does like community health, another one who's a generalist at a hospital, another one who does big data analytics for how genetics influence disease outcomes, that kind of stuff. So a lot of different things in the biomedical field that I think would interest you guys. So I'll try to organize and find funding for that so we can have food so you guys come have dinner and not be hungry during class like I am right now. All right, let's go ahead. Question up here. I want you guys to submit your answer. This is going to kind of set the stage for today. Once you've submitted your own answer, you can check with your neighbor. A couple more seconds. All right, we have 44 responses. Can I hear from a new voice if you notice? Do you guys find it beneficial when you hear from the same voices every single week from the student population? Not only does it offer a more diverse perspective when everyone pitches in with their ideas, it also helps a lot when you hear someone who has the same approach as you, especially if it's not right. There's a huge amount of value to being willing to share the way that you got to an answer, even if the answer is not correct. People in class learn way more. So I highly encourage you to be willing to share your thoughts, especially when you're not confident or when you know where you've reached your limitations. Say, well, based on this and this, I got this far, but then I guessed because I couldn't figure out the rest of it. Super useful. So try to push yourself this semester. I try to make sure to be respectful of people who don't like being cold called. So if you are terrified of being cold called, that means calling without you raising your hand, you can send me an email and let me know. I will be mindful of that and I will try not to call on you. But I will encourage those people to then raise their hand as much as they can, convince themselves to feel comfortable with, okay? So I'd like to hear from a new voice. Humphrey, sorry.
Small partial negative charge.
Why?
Because O has a larger electronegativity than H.
Okay, great. And they're sharing a covalent bond, so those electrons are pushed a little bit more towards oxygen. It has a partial negative charge. Fantastic. I see 49 responses. Is everyone in OWL? Because I'm not sure I saw 49 people completed OWL. Was everyone able to get in and do today's pre-class quiz? Okay, hopefully so. Question?
So it didn't let me submit it, it just said save and exit.
Okay. As soon as the deadline passes, it'll submit it automatically. So maybe for those it doesn't do that. So I wouldn't worry.
Mine, like I got it out today and it was like the same quiz as the last class, is that correct? Because you only had that one.
No, so we can talk after class about that. It should have been on intermolecular forces. All right, we'll chat because that's you don't want to be left out. So every class, I try to start with outlining what it is I want you to be able to do by the end of class. My goal is not for you to come here and to be exposed to a whole bunch of stuff. You guys have noticed that already, right? I'm not just going to vomit on you, word vomit. I want you at the end of class to make sure you're able to identify relative polarity of molecules. So is this more polar than that? This is going to be your study guide. I don't give study guides for this class. At the exams, I give them now. So at exam time, you can add these up, or after every class, I post the slides. You can go and you can pull these from the slides, and you can make your own running list of it. Make sure that you're able to do these things. And check back in, even at the end of class. Take a look.
Something that I kind of stumbled upon that I didn't know that you were doing was the audio recordings of each class session. So
so it was
Video,
kind of,
yeah.
yeah, it was kind of interesting to go back and listen to it.
So if you are close to this, it is recording audio and whatever's being fed to the screen, including what I draw. I post that to YouTube. So if you miss a class, then you should go back, download whatever materials we had in class, which are in content, and then watch the video and follow along as if you were in class. It's the best way to do it. That's why I record. I don't typically have students that don't show up to class and watch this instead. So hopefully you find being here valuable working with your peers. All right. I want you to be able to compare and contrast the relative strength of intermolecular forces that exist between molecules, which hopefully you've identified some of. We're going to do a lot of stuff with predicting the relative boiling points of pure samples. That means if you have only one compound, you have a lot of it, what does it take to boil that compound? And then basically looking at a molecule, predicting what the strongest IMF is that's possible, intermolecular force, based on the functional groups present. We're going to start to use some chemical nomenclature. Did I miss something, Jason? And let's see if we can get some audio. Have a little video to set the stage. Hopefully we can hear.
The magnitude 5.6 quake centered near the city of Pawnee had a state record and was felt in 7 states. A powerful earthquake rattled central Oklahoma Saturday. The magnitude 5.6 quake centered near the city of Pawnee had a state record and was felt in 7 states. It also renewed concerns about the disposal of wastewater from oil and gas production, which has been linked to the recent outbreak of quakes in Oklahoma. Here's Mireya Villarreal.
The facade came down off this old building here on 6th Street.
Bricks and debris from historical buildings in Pawnee, Oklahoma cover the sidewalks. This small city is the latest epicenter of concern over Oklahoma's oil and gas industry.
It was bad. The whole thing was just going like this. It was bad.
In 2015, Oklahoma averaged 2.5 earthquakes a day with a magnitude of 3.0 or higher. A total of 907 at that rating shook the state last year, compared to just 2 in 2008. Oklahoma Geological Survey experts have connected the increase in quakes to the disposal of wastewater from an oil and gas production process known as hydraulic fracturing or fracking. Saturday's quake prompted the state to initiate the fastest and largest shutdown of wastewater wells in state history. 37 are scheduled to be closed.
If we stopped all the activity tomorrow, it's not like the earthquakes would stop tomorrow.
Seismologist Susan Huff of the U.S. Geological Survey says induced earthquakes, mainly caused by wastewater injection wells, aren't as severe as naturally caused ones. But that could change if Oklahoma and other states where fracking is booming don't take note.
Is there a chance things could get worse? We expect that the regulatory steps are going to help overall, the rates are going to go down, and the hazard will go down. But we don't have an exact crystal ball, and so there's the potential, certainly for more earthquakes. There's the potential for bigger earthquakes than what we've seen.
The 37 wastewater wells that are set to be shut down are just a small fraction of the 4,200 currently permitted by the state. Elaine, the Oklahoma governor has declared a state of emergency for the affected area.
All right. So that's going to set the stage for one of the many applications of intermolecular forces. One of the activities you guys picked up today was on hydraulic fracturing. This one right here. This is going to be our supplemental instruction material for the week. So Josh, can you stand for a second? So Josh Henrik, many of you may recognize him. He was in our Gen Chem class this fall, but he is actually a BS chemistry major graduating this spring. He is very knowledgeable in chemistry, and he is going to be leading our supplemental instruction this spring. Based on the times that you guys reply to the doodle poll, the times for supplemental instruction will be tomorrow, 4:30 to 6 p.m., and Saturday, 2 to 3:30. Is that right? The Saturday one is going to be Zoom-based, which means it's going to be online, a virtual meeting, and you will get a link, which you will click to log in, and then Josh will be facilitating that digitally, trying to get you guys to work on it, bring you together for questions throughout. It's going to be similar to the way that we do local activities in class, but we're going to try to do this online. Tomorrow is going to be in person. The location of that, I need confirmation from the chemistry department, so I do not have that location yet. Can I say a show of hands for how many people will come tomorrow to that supplemental instruction? That will help me figure out the space. It's about like 20 people, 15, 20. I will send an announcement out tomorrow to let you guys know where that is going to be. If I zoom way out, the reason we're doing supplemental instruction is because these concepts are hard. I want to help you connect them to your prior knowledge and to real-world applications, which is this one does both. I don't want to penalize people who can't make those 2 times a week, so you can still complete the activity. You can turn it in to me in class on Monday, and if you work through it and actually attempted to do it appropriately, then you get credit for the supplemental instruction for that week. The way I'm trying to do it is to make so if you complete 75% of the supplemental instructions, either by completing the packet and handing it in, or by going and just attending the whole time, which most likely you will complete the activity during that time as well. If you do either one of those 75% of the time, then that's full credit for supplemental instruction. We're trying to build this in where it's not a burden, or it's an additional resource to help you. Danielle?
So what do I do if I don't get off till 5? Can I come after that?
For tomorrow?
Yes.
Good question. I imagine the activities will start at 4:30. Maybe if you have time tonight or before then, start the activity and then come join the group. That might be the best way to do it.
So just do that every week?
Wait, tomorrow's 4:30, so it'd be half an hour late. That's a potential. You could also ask about potentially shifting your schedule, because I know you're employer, so maybe that's possible. Maybe not. I don't know. Right, but I don't know if you shift hours somewhere or something like that.
You're gonna have to work more.
Will it be at the same time and day and place
Yes.
every week?
Based on the doodle poll, that is the time that works, and so I don't want to shift that, if at all possible. All right, any other questions about supplemental instruction? Yes, Brianna?
So I know for sure that I work at a workplace that's not going to let me off before 5.
Fair.
So it'll be about 5:20. I know I can attend the Saturday one. Is it one a week, or you prefer for us to be at both?
Any of the 3 options works. Completing it on your own, which I don't think you'll get as much out, but if that's your only option, do it. I don't want to penalize you for not being able to go. Or if you can go to the Thursday, or if you can go to the Saturday. I'm not adding 3 hours activities to your week. And to be honest, Josh and I talked about if these activities take an hour, and you go to supplemental instruction, if you're there for an hour, and then the last half hour will be question and answer, like other stuff in class. You can harass Josh all you want, and he'll have to be responsible for answering a lot of questions, or you can leave. So I think plan on about an hour of actual engaged doing the activity. It might run longer if there's a lot of questions. That's what I'm planning. So that's why showing you 5:20 for that hour and a half is halfway through, so I don't know that's going to be that valuable. I would do Saturday for you.
So we do, either way it goes, you have to turn it in, because I was...
Nope. If you go Thursday or Saturday, Josh will keep track of who is attending, and if you are engaged and participating, which isn't asking too much, then you get credit for that.
Okay,
If you don't go Thursday or Saturday, then you turn it in, and we'll get it back to you hopefully by Wednesday. Any other questions? This is something new we're trying. We've gotten funding from the provost office because they think it's a good idea. This class typically has a history of people not passing as much as we would like. So this is one attempt we have in order to increase the success rate in this class. I think it has potential to do good. So not only will you get 4% of your class grade by doing this, we hope that that encouragement, the point of encouragement, will also get you to succeed in many other ways in the class. Any other questions? Hope it's clear. If this model is terrible, or you think it's terrible, please let me know. If you think there's ways we can tweak it to improve it, please let me know. We are trying to do what's best for you guys, and if it's not feeling like it's best for you guys, then we're happy to alter that. I am flexible. So this is the activity you guys will be working on. The PDF is also put in Blackboard, so if you want to see the color version, you can do that. The Zoom meeting that we have on Saturday that you'll get a link for if you decide to do that one. Josh may do screen shares and share this kind of stuff, so you might be able to see some of that way, but it is a digital PDF you have access to as well. All right, so before we start the other activity that we have for today, let's just have you guys answer this question.
You said Saturday was 1 to 2?
2 to 3:30, I think. It's in the announcement I sent out yesterday. I never got an email from you about the bottle deposit thing. Last class, you said you were interested in the bottle deposit? Nope.
I was like, if you haven't done it, I already told my friends about it again.
Awesome. Do you think this is a big misconception that people have? Majority of people say that false. So they say when water evaporates, bonds between O and H atoms within the molecule are not broken, is what you guys are saying. What is broken? Danielle, you want to raise your hand? Say nice and clear. Go ahead.
Okay, so the bonds between two different water molecules.
Okay, great. And how can we enhance that statement even more? Ruby? Great, so you replace the word bonds with intermolecular forces. Okay? And that's a really critical distinction. If you're a biologist, you guys are wrong. You call them hydrogen bonds. That is one of the biggest misnomers in all of science. What is a bond? What is the definition of a bond? Hands raised so I can hear one clear answer when you guys have something clear. What is a bond? Aaron? Sharing 2 electrons between 2 atoms. Why do they form a bond? To increase stability. Specifically, how are they increasing stability? What are 2 atoms doing sharing electrons? Matt?
They're trying to get to a noble gas configuration.
Great. So they have some number of valence electrons. It is not a noble gas configuration, and so they're trying to share their valence electrons with someone else's valence electrons to make it look like all the shared electrons are theirs. So it's a more stable octet or duet configuration. Right? That is a bond. That is a chemical bond. If we change that, we're doing a chemical reaction. If we boil water, when water evaporates, whether it's boiling or not, are we taking water and doing a chemical reaction to it? I want us thinking very carefully about what is changing during boiling, and this activity is going to help us do that. Kayla, you have a question? Okay. So go ahead and get started on Chem Activity 27. Carefully read Model 1. It's a lot of information, and then once you've answered those 2 questions, which is kind of what we just talked about, you'll jump into Model 2, and you have a lot of data there we need to interpret. We have a number of facilitators again today. We have Janesh, Nabil, Josh, Emily, and Peter. So all of us will be walking around to help you once you get started. So there should be 2 piles always, one back there and one over there.
Follow me everywhere, sir. Follow me down.
Yes. Well, so we shouldn't talk that long. Just not right. I might. Maybe it's because there's so many numbers today, so maybe one of you guys
Oh.
Raise your hand if you don't have a packet for packet 27. Okay, can you hand the extra? I swore I printed out like 50 some of these. Okay, Echo has one. What's that?
You can go and print some real
The
fast.
fracking package is okay, we can do that before the end class. But the activity 27, who does not have activity 27? If they don't have activity 27, can you give one of them there?
She just got one.
Yeah, so let me just do one last check. One more time. If you don't have activity 27, raise your hand. Activity 27. Everyone has activity 27? Everyone has it? Is there anyone who does not? Raise your hand if you do not. Moe, do you have it? Okay, just grab the ones off the printer and then the supplemental ones. Thanks.
I got you. Huh? No, I don't know. I got the presentation with
I actually went to the library and read all the
Cool.
Yeah, just I'll let you know when I'll let you know. Yeah, I got that.
We look at
You're taking two. And also, keep in mind, he's getting paid $4,000 more than the one of it's just literally out here.
if so, now give us an idea of that kind of gets you going. Didn't answer your question. That's the kind of stuff that really works down. Examples, we go through probably maybe you understood why then. If not, you understood why now. You just gotta keep going.
It was, I was didn't have any.
There's like this where my couple of that's so that would be So let's talk
Wait. What is different?
lower left. No, you always have to do it right.
Think about it. Breaking with. Not voluntary. So think of another way to say that. That makes sense.
Whatever scissors you find.
It's asking to rank the regression compounds and she also pays for all. So, like, I mean, not is that saying like the reason why it takes a higher boiling point is because the intermolecular forces are more stronger? So, you're right. Okay. Just making sure. You're right. That's kind of what I'm thinking, but I do when I was looking at that one, I'm not even there. So
I said, what's the norm point of the first year? It's like ethanol, chlorine. No.
Look, buddy. I don't need.
I didn't say you did. I said you like to go back and work in the
No, it's fine.
I was not trying to say you need to.
Repeating the same stuff. We had a good dialogue. Instead of directly.
Yes.
No, Hepta, hexa, hepta, hepta 7. Sorry, it took me a second.
I didn't know that. Okay, well, I thought it was 7 because obviously it's a hexa and it was a penta and it's below deca. But I didn't know if it was like.
Still the same. Alright. And that's the same thing as this.
It looks nice.
You were right. Austin was right. Oh.
You ever see like a TV?
It's so nice to have them.
No, but have you ever seen like a TV with like static going across the screen?
Oh, okay, that does make sense. Yeah, it does, like, but it's still cute. It's a cute static.
Okay, so it's
Well, it goes. Well, it's consensus.
But there's not induced dipole.
Then it's
okay. I did all the homework in ground setting. Then I was like, the hydrogen is something. That's literally my motto. I might get it right, but I have no clue what I'm doing. So based on the data, can we do the presence of that increase the strength of interaction? So it's asking how does it play a role in the strength of interaction?
That doesn't make sense.
The answer's wrong.
All right, let's check in, make sure everyone's on the same page. We're moving forward. You guys feel pretty comfortable with Model 1, asking about water attraction between water molecules? Yep. Any questions on that? So it's all about proximity, and we're going to be talking a little bit about Coulomb's law as well. We'll do that a little bit later on in class. Model 2, what is Model 2 getting at? Can I get some people to summarize the take-homes from Model 2 that it has from making you look at different compounds within and between groups? Can I have 2 or 3 volunteers with different ideas?
You're looking at the relationship between intermolecular interactions or attractions in comparison to your boiling points, and then also those 3 different types of compounds and the relationships that you can find in those 3.
Great, so we're looking at 3 different types of compounds. What's the difference between those types of compounds?
The types of bonds they have, so if it's a carbon and a hydrogen, that was for alkanes, and then the ketones was carbon and oxygen, and alcohols were oxygen and...
Okay, and so let's be careful though, because all of those molecules have CH and CC bonds. So the distinguishing factor between them is that alkanes have only carbon-carbon hydrogen. Ketone, by definition, a ketone means a carbon connected to an oxygen with 2 carbons on either side of the carbon. So we're going to start talking about functional groups in this class because it is chemistry. So a ketone is carbon-carbon-carbon with an oxygen. An alkane is something with only carbon-carbon-carbon hydrogen, single bonds. And then the last group is alcohol. What is an alcohol? Is that Anthony? Maybe I'm glad I didn't hear what you said. Okay, from a chemistry standpoint, what is an alcohol? And yes, drinking alcohol has an alcohol on it. That's why it's called alcohol, because it's the most common one. Carol? OH, but really important, what's connected to the O? It's a carbon and The fact that it is not connected to another, this carbon is not connected to another oxygen makes that an alcohol. If you have this, one of the biggest mistakes that chemistry students make when they're learning about these functional groups, these groups that function a certain way, is they call this an alcohol. This is not an alcohol anymore. Once the carbon has a double bonded oxygen, this is now a carboxylic acid. Okay? So an alcohol is carbon with, doesn't matter what's connected to it, as long as it's not a double bond to an O on that carbon. Okay?
And on the other one, the ketone, the O has to be connected to a carbon that is double bonded to carbon.
All those have to be carbons, yes. If you have, this is an oxygen, that's a different functional group. This is a hydrogen, that's a different functional group. Okay? So all these things change. I don't want to know. Okay, so we have groups of molecules that have different functional groups, groups that make them function different, as we can see from the bullet points, right? Okay, so then let's talk about what trends do we see from those different groups. Can I get another volunteer? What are the trends that we're starting to see? Kayla? Good. Sorry, Kalia.
It's okay. As the molecular weight increases in all the groups, I saw that the boiling point increases.
Fantastic. Really important. As the molecules increase in molecular weight, boiling point goes up. And we're going to talk a little bit more about why in a second. Another observation. Logan.
So as the difference between the alkanes, the ketones, and alcohol, even when you find molecules with relatively the same molecular weight, you can notice that the alcohol has a higher boiling point than the alkanes because, well, the reason we found was because that alcohol is polar, so it'll have a stronger molecular forces with the other molecules it has.
Great, so we know that an alcohol, carbon, oxygen, hydrogen, with no double bond to oxygen on that, compared to an alkane. If you're not familiar with line structures, if you didn't have that in your previous chemistry class, that's a good thing to come in office hours and talk about. What this means, carbon, 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 how many hydrogens they have, all that kind of stuff. So that's something that we're not going to spend time in this class. So if you need to review that, come meet with me and I'll get you up to speed. So polar, nonpolar, higher boiling point, lower boiling point. What about ketone? Ketone's also polar. Is that a higher boiling point or lower boiling point than those two? Is it in the middle? Why? It's polar. Shouldn't it be the same?
It's not as polar without the alcohol.
So I heard a lot of people talking about the difference in electronegativity between carbon and oxygen makes it a polar bond, as opposed to carbon-carbon or carbon-hydrogen. Those are nonpolar. But over here, not only do we have a carbon-oxygen that's polar, we also have an oxygen-hydrogen. That is even more polar. And so that makes it nonpolar, medium polar, high polar. So I want us thinking about that as we move forward. Any other conclusions looking at the data in those three tables so far? Okay. Go ahead and, if you have not already, start working on Model 3. Make sure that you carefully read that, focusing on the difference between intra and intermolecular bonds. And they're going to refer back to the data and make some predictions as well.
Okay, and then enter.
Adam's gonna be
like oxygen and hydrogen.
Oh, is it not stuck on it, yes.
Yeah, or the
I'm in biology. I don't know if I mixed up my head.
because when you look at biology, it says
In terms of what there was Doc said that hydrogen bonding is like, okay, so in terms of bonding, but no diagnosis, right? So now in terms of fitting in very closely with the other items, right? It says the hydrogen bonding is not cracked itself, and it's literally like, is that it? We made it, okay,
So next one is the ketone.
Yeah, so hydrogen would be the highest.
I'm not trying to like confuse.
Okay, what?
That whole thing.
So one last question I wanted to get hear you guys' response to was question 10, right before model 3. Is the strength of intermolecular forces determined by the bond strength within the individual molecule? Can I hear from someone your thoughts on that? Jonathan?
Well, what I thought was it's going to depend on what is making the bonds and not necessarily the bond itself.
Okay, so this one really is specifically asking about the bond strength. So that's half of the answer, is that the atom's identity is more important than the bond's strength. What is it referring to as bond strength? What is it trying to get at? What is it having you compare between those different sets of compounds?
Between the polar, I think, the ketones and the alkyl group, which are both.
So there's a little bit of it that's about, so it really does come down to the polarity, right? It's what's bonded to what. But why is it asking about strength? What is that trying to focus on? Did anyone catch that? Do any of these molecules have stronger bonds within them than the others? What do the ketones have that none of the others do? Double bond. Double bonds are stronger. They share 4 electrons. They're shorter. They have a stronger bond in them, but that doesn't influence the inner strength of the intermolecular force, and hence the boiling point, nearly as much as whether they have polar bonds and how polar those bonds are. Okay, we're going to spend a little bit of time. We're going to shift gears, and then we'll come back to the rest of the activity. I want...
What was
What?
the answer? What's the definite answer at number 10? Because I'm confused.
Someone like to summarize the definite answer for number 10? Savannah?
We wrote that intermolecular bonds are bonds between atoms within a molecule, and then intermolecular is bonds between 2 molecules.
Okay, so instead of using bonds between 2 molecules...
That's 11. I know 11.
10.
Okay. I wasn't quite sure if you were getting... So question 10 about bond strength, Logan.
I said no because they are determined by the interactions. It's not an actual bond. It's the forces that are actual bond. But that's why when they're polar, they're closer together. I guess, so they're stronger.
Yeah, we're still kind of dancing around it a little bit. Moed?
Answering question 10, right?
Yes.
I said that no, it's based on the strength of intermolecular forces between molecules because the independent bonds, no matter how strong or weak they are, aren't going to affect the attraction of different molecules between each other. And those interactions between different molecules is what holds them back, holds them together, which is why they're called intermolecular forces. And then the types of bonds are more the types of different atoms that are connected or bonded together, and their difference in polarity, electronegativity would influence intermolecular forces regardless of the strength of their bonds.
So I think that is a very full answer to the question. And the question, I think what your answer, if I can distill it down, polarity matters, bond strength is irrelevant, if they're not polar bonds. Here's a great example, acetylene, right? Acetylene torches. Hydrogen, carbon, carbon, hydrogen. Triple bond, extremely strong bond. Non-polar. Going to have a very low boiling point. It's a gas at room temperature. Does that answer your question? Clearly?
Yes.
Okay. Let's talk about vapor pressure, because everyone wants to talk about vapor pressure. Which sample, and I'm going to do this as a quicker question, even though it's not really set up exactly that way. I'll do it here in 1 second. I want you to tell me select one of those 3, A, B, or C. Which one of those 3 compounds has a higher vapor pressure at room temperature? Think about what that word is. Think about what vapor means, what pressure means, and think about which one of those 3. You have your table, so I just kind of highlighted 3 that all have about the same molar mass. They're all about 70 grams per mole. Talk to your neighbor. Try to figure out what vapor pressure might mean so you can answer this question.
Yeah, like I feel bored.
So it would have.
Go ahead and submit your answer. Couple more seconds. All right, first thing, we have one of these answers that has the majority of the votes. That is answer A. May or may not be right. I want to hear definition, maybe your own group's definition of what you think vapor pressure might mean. If we have 3 different samples of these molecules, all at room temperature, what are we talking about vapor pressure? Can I hear from new voices? I heard a lot of really good discussion as I was walking around the room. New voices, new voices, new voices. Please. Can I hear from a group in that back corner? Sure, if you'd like to, or any of the groups right around you.
We said A as well, with the majority of our peers, because we felt like since the molecules were packed more tightly together, there would be more pressure.
What do you mean packed more tightly together? Can you be a little bit more descriptive?
The forces between molecules are stronger. The intermolecular forces, because the boiling point it was higher, was kind of the generalization we made.
Wait. So let's make sure we're all talking about the same thing. You said A.
Or it was lower, so the intermolecular forces were lower.
Okay. You said the exact opposite the 2 different times. Yeah. So which one are you settling on? Final answer.
The second one.
Okay. So it has a lower boiling point. The intermolecular forces are lower.
Yeah.
So what does that mean? How does that relate to vapor pressure? What do you think that?
We were Googling vapor pressure definitions as
use your resources, it's all good.
I was just thinking that there's a chance you're maybe losing some molecules to the atmosphere at that point, and since the forces are pulling them together aren't as strong, more of them are being lost to the atmosphere.
More of them are evaporating.
Yeah.
And one of the things we'll talk about in class next week is that there's a distribution of molecules at different speeds. So if you were to sample in a liquid, the warmer the sample is, the faster those molecules are moving around. And that means that some of them have enough speed to overcome those intermolecular forces and become a gas. If you're much closer to the boiling point, you're going to have more of them that can overcome that intermolecular force. So you have more of these molecules in the gas phase than these ketones, more ketones in the gas phase than the alcohols. So let's think about the specific term, vapor pressure. What does that mean? You want to answer that, Logan?
Well, the way I looked at it was like if we had those gases in like a canister or like in a contain, like at those points, like the closer the boiling point, the higher, the more the pressure would be in the canister if it was sealed. So like, is that related? That was really a question.
So you're saying just basic gas laws that the warmer it is, the faster the particles move? Is that what you're saying? I'm sorry, I didn't quite follow.
Like breaking the intermolecular forces, so therefore making the more pressure that'll be free instead of like.
Where does the pressure come from? That's what I want to get at.
It breaks the molecule breaking the intermolecular forces.
What's the pressure? What's the pressure? Let's go back to gas laws. When we talked about gas laws first semester, where's the pressure coming from? Remember, Jason?
It's the impacts.
Impact with what and what?
With the atoms and
molecules.
Molecules and whatever container you might have inside.
Great. So the really important thing that I tried to impart on our class this fall was that gas laws, if you're thinking about how pressure relates to everything else, if we go into Magic School Bus and we look at the gas that's above a liquid, that gas is a whole bunch of little molecules that are moving around and bouncing. And pressure is a measure of how hard those molecules hit the side of the container, how heavy those molecules are, what speed they have, and how frequent they hit the side. So vapor pressure is a way of measuring, well, how much of the molecule is in the gas phase above a liquid. If we're closer to the boiling point, we're going to have a lot more molecules in the gas phase. So the vapor pressure is something that you guys will see in your homework a little bit. And I wanted you to kind of have a little bit of an idea. We're thinking about gases and pressure. Always think about the molecular perspective of molecules colliding with the outside of a container. That's how we measure pressure. All right. So I totally agree with the class. I just always start out by saying I may or may not agree because I don't want to bias the discussion. All right. So let's do a couple of lightning round clicker questions. Means super fast. Water is... Couple seconds. Uh-oh. Uh-oh. Well, it's okay. We only have 9 minutes, 10 minutes left class. All right. So I really hope the majority of the class answers this the same. Most of us say it's polar. Boiling point, 100 degrees Celsius. Relatively small compound, right? 18 grams per mole. But the boiling point is off the charts compared to some of these other compounds we looked at. All right. Carbon dioxide. Let's talk about, I think we should be able to answer the second part of this question. Carbon dioxide is, which of those answers at the bottom is appropriate? Let's see the little battery power here. All right, we have a distribution. Does it have polar bonds? It does have polar bonds, but where is the center of the positive and negative charge? Partial positive, partial negative. Are they on top of each other or are they different? So it's a nonpolar molecule. All right, boiling point of carbon dioxide. It's actually a sublimation point. Goes when it becomes a gas is minus 78 degrees Celsius. 178 degrees colder than water. And it weighs more. All right? Sodium chloride. Can we say this without answering it? Yeah. Sodium chloride. Sodium has a full or partial charge? Full charge. And the sodium is a positive or negative? Positive. All right? Boiling point, 1400 degrees Celsius. So if we look at sodium chloride, it's always going to be multiple sodiums and multiple chlorides. We're not talking about just two by themselves. So then what is responsible for those attractions? What characteristic results in a stronger attraction? This is a table that summarizes what we just talked about. Are we going to have a stronger attraction? I'll just let you guys read. Go ahead and talk to your neighbor if you want to see. Which one of these and why? Is it an obvious answer? Sarah, would you like to describe what you guys discussed?
Two particles with full charges because ionic forces are stronger, the strongest one.
And how do we know it's the strongest attraction? So how do we know that? What data do we have that supports that? This is insane. Okay, so what I was thinking about is the weaker the attraction between the two things, the easier it is to pull them apart. What that means is, I think we're going to skip that one for right now. I want us to look at all of these, and I want you guys to determine which of these intermolecular forces do you think is the strongest? And this is induced dipole. Induced dipole, I think, is the way you guys have seen that written in this version. Couple more seconds. Closing out. $50-50. Talk to your neighbor. Try to distinguish between C and E. And I want you thinking quantitatively. Think about what we just talked about and think about how to support your answer. All right, so your new vote. Vote again. Do it again. Couple more seconds. All right, we had a shift. Now we have 2-to-1 response and answers. Can someone who changed their mind volunteer to share what you changed your mind to and why you were convinced to change your mind or why you decided to change your mind? Matt?
I originally put C because I was automatically thinking hydrogen bomb. I switched it to E because sodium dissolved in water, which is what that looks like, would actually have a full charge as an ion.
So there's a full charge positive ion there.
And then therefore it would attract the partial water molecules around it.
So the question really is, if you have a hydrogen bond, which is interaction between a partial positive hydrogen on one side and a partial negative on the other side, is that a stronger interaction between two partials or between a full charge and a partial charge? What do you guys think? Full charge is going to have a stronger interaction. All right, so the class shifted in that direction. So E is definitely the stronger. And Coulomb's law is a way to mathematically support that. So the strength of the two charges divided by the distance between them. So the stronger the charge, the partial or the full charge, the stronger the attractive force is and the more energy is required to pull them apart. So there's a way that you can categorize these, and I'll post this online as well. We still have 2 minutes, by the way. That clock's off. I use every second of class. I want us thinking about how to categorize how strong these are. I put together a flow chart, but I really want you thinking about the magnitude of the partial charge or full charge. If there are no ions present, then I want us thinking about the types of intermolecular forces that can exist between two different molecules or ions. If they're not ions, you're not going to use ions, right? You want to say, are there polar bonds on either of the two? If no, what kind of interactions can you have between two molecules with no polar bonds? London dispersion, which are also called induced dipole, or dispersion forces. There's a few different names. So London dispersion forces. If there are polar components of those molecules, what can it be? What can the intermolecular forces be? Ruby? Dipole. And let's stop there. Everything that has polar molecules and attractions between the two polar molecules, that is dipole. End of story. But not really. Then the biologist said, well, there's some special dipoles that have particularly strong dipoles. What do we call the ones that are particularly strong? So if they do have an electropositive hydrogen that's having electrons withdrawn from it, and then on the other molecule we have something with lone pairs, usually nitrogen or oxygen, then that is a very strong dipole. But don't be fooled. These are all dipole, right? They're just some stronger than others, so we give it a special name because biologists like to. On the other side, if there's ions, we can either have ion dipole or ionic bonding. So I'll post this slide online. You're welcome to kind of use this, but I want you kind of thinking through how everything fits together. I would highly advise going through the rest of the packet. Once you have all those names, try to figure out how everything fits together. And hopefully we'll see a lot of you tomorrow at the supplemental instruction. What's that? Yeah. Logan, what did you say?
It was like